Hello friends, welcome to engineering tutorial. Today we are going to start a new topic. So before you continue with this video, I would like that you see my other videos related to signals and basic concepts about modulation and the need for modulation in my channel so that you understand this in a better way. Okay, please check my video related to signal characteristics and basic concepts about signals and the basic concept about modulation before uh, uh, watching this video. And if you have basic idea about modulation and your basics are all right, you can continue with this. Okay, so today we are going to start about amplitude modulation. Okay, so what is amplitude modulation? Now in amplitude modulation, the amplitude of the carrier signal is changed or modulated according to the message or modulating signal. The frequency and phase of the carrier signal remains the same. So as I said, in amplitude modulation, the parameter which changes or gets varied is the amplitude of the carrier signal, the high frequency carrier signal, depending on or proportional to the message signal or the modulating signal which contains the necessary data or information. Now the process of modulation consists of two signals. We all know that the message or the modulating or the baseband signal. These are some of the names of message signal. You can call it message signal, you can call it modulating signal, you can call it baseband signal. They are all the same. This is the signal which contains the data or information which is to be transmitted from one point to another. But this the deficiency of the message signal is that it is of low frequency. It is generally in the audio frequency range, and audio frequency signals have very low frequency, and as a result of that they have very low energy content, so they cannot be transmitted over long distances. So we need a high frequency carrier signal which carries the message signal over long distances. So it is the amplitude of this carrier signal which is varied proportional to the message signal. So the modulation concept or the modulation process consists of the message signal, a modulating or baseband signal which is of low frequency and low energy. It contains the necessary data or information which is to be transmitted, and we need the carrier signal which is of high frequency and high energy content to carry the message signal. So in amplitude modulation, the amplitude of the carrier signal is varied, okay, and the variation is proportional to the message signal. The frequency and phase of the carrier signal remain the same. They are not touched at all. They are the same. They remain constant. Only the amplitude of the carrier signal proportional to the message signal is changed. So how it happens? We will have a look at the mathematical description of amplitude modulation. So let us write the carrier signal as Ct, or C as a function of t, as Ec cos omega Ct. Here Ec is the amplitude of the carrier signal, omega subscript c is the angular frequency of the carrier signal. Okay, here I have taken a cosine signal because it is easier for mathematical analysis. You can also take a sine signal, there is no problem, but here for easier analysis, for simplicity in calculation, I have taken a cosine signal. You can take a sine signal, there is nothing to be confused about. You can take sine signal, you can say cosine signal. Here I have taken a cosine signal. And the message signal, let us write it as mt, as Em cos omega mt. Here Em is the amplitude of the message signal and omega m is the angular frequency of the message signal in radians per second. So, as I said, the frequency of the carrier signal is more than the frequency of the message signal. So, generally another important part to understand is that generally the signal is represented as this, with the amplitude, the angular frequency and the initial phase. This part is important. But here, for simplicity, we have taken the initial phase of both the signals as 0. Means at the starting point, the phase angle of the signal, the initial phase is 0. It starts from the origin. At the point of origin, the initial phase is 0. Okay, for simplicity in calculations, we have taken that. Okay, in both the signals, you can see here the initial phase angles are 0. So, these are the representation of the carrier signal and message signal. Now, let us see how amplitude modulation takes place. So, here, as we know, in amplitude modulation, the amplitude of the carrier signal is changed proportional to the message signal. Okay, so here the amplitude modulated signal E subscript am as a function of t is given as, here it is the amplitude of the carrier signal. Here it is varied proportional to the message signal. Okay, so you can write it as EMT or EAMT is equal to EC plus KMT cos omega ct. Here K is equal to 1. Okay. Here the amplitude of the carrier signal is varied proportional to the message signal. Here the message signal is Em cos omega mt. Here the proportionality factor we have deliberately selected as 1 for simpler calculations. See, the angular frequency remains unchanged. It remains omega c as it was before. Only the amplitude of the carrier signal EC, an extra factor Em cos omega mt is added to it. The angular frequency remains the same and the initial phase was 0, so that does not come into play here. Understand it. Only this parameter, this part Em cos omega mt, or this part is added to the amplitude of the carrier signal. Okay, so this thing is the time varying amplitude of the amplitude modulated signal. Okay, so the amplitude modulated signal is equal to EAM, E subscript AM, the time varying amplitude cos omega ct. Here EAM is equal to EC plus EM cos omega mt, which is the time varying amplitude of the carrier signal of the amplitude modulated signal waveform. This part is also called as the envelope of the amplitude modulated signal waveform. It is the outer boundary, the amplitude of the outer boundary of the signal waveform. Again, pay close attention. This factor Em cos omega mt is added to the amplitude of the carrier signal. This process is called this part constitutes the modulation process. The frequency of the carrier signal remains as it is, omega c. There is no change to it, and the initial phase was 0, so that does not come into play here. So this is the amplitude modulation, or the mathematical equation for the amplitude modulated waveform. So let us see the signal waveforms that are involved in amplitude modulation. So here the message signal, we have used a cosine signal. Of of course the time period is very high and frequency is low of the message signal. As a result, it has low energy. The carrier signal also a cosine signal, EC cos omega CT. Here the frequency is more as the time period is less. As a result, because of high frequency, it has high energy content. Okay. So here this waveform is the interesting part, which is the amplitude modulated signal. So if you have a look at it, the frequency of the waveform is the same as that of the carrier signal. The frequency of the amplitude modulated signal is the same as that of the carrier signal because there is no change in the frequency of the carrier signal. Okay. Now you can relate, the carrier signal frequency remains unchanged. So the amplitude of the amplitude modulated signal is the same as that of the carrier signal. The only thing which appears to have a change here is the amplitude. Okay, the amplitude changes proportional to the message signal. So if you compare these two waveforms, first you have a look at this and you see this, you will see that this is the envelope which I was talking about. Okay, having a time varying amplitude EC plus EM cos omega mt, which is the positive part, and this is the negative minus EC plus EM cos omega mt. This is the maximum amplitude of the amplitude modulated signal, which is Emax, which is EC plus EM, and this is the minimum amplitude of the amplitude modulated signal, which is given by EC minus EM. This is the outer boundaries. These are in which the two outer boundaries at the top and the bottom constitute the envelope of the amplitude modulated waveform. Here only the amplitude of the carrier signal has changed proportional to the message signal. Okay, EC plus EM cos omega mt cos omega CT, while the frequency has remained unchanged. This frequency is the same as that of the carrier signal, and no change has happened to the phase. The initial phase was 0 and here it is also 0 because it was never in question. The initial phase was always considered 0. So that has no part to play here. The two important things to remember here is that only the amplitude of the carrier signal has changed. This is the time varying amplitude. Okay, while the frequency of this amplitude modulated signal is the same as that of the carrier frequency, or the frequency of the carrier signal, and this is the time varying amplitude, which is the envelope at the top and the bottom of the amplitude modulated signal. So here I have discussed some of the basic concepts related to the formation of the amplitude modulated signal. In my next video I will be discussing about other parameters such as modulation index, then the power efficiency, and the various types of characteristics or features which are associated with an amplitude modulated signal. So please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, telecommunication and instrumentation engineering. Have a great day. Thank you very much.